Okay, cool. Yeah, I think we can start now. Can you hear me? Yes? Okay, cool. Perfect. Yeah, thank you so much, everyone, for your time today. We are in North America, also people are in Asia, in China. For us, it's evening, for you, morning, for sure. Welcome to the sessions, the Python Bootcamp, Internet Computer Bootcamp. We are preparing 6 sessions. This is the first one. Will be Fridays and Saturdays during the next 3 weeks. This initiative is organized by the ICP.Hub North America, a major contributor to the Internet Computer blockchain in Canada and the US, and also by Demergent Labs. Here we have the CEO, Jordan Last, that will be the person that hosts the sessions. And also we are collaborating with DKU Computer Science Club and DKU Finance Club. Thank you, Alan, as well as Scotty, for your time and your organization. Yeah, let's start. 1 second. Yeah, this is the first session, Build on the Internet Computer Python Bootcamp. In this bootcamp, the idea is try to get the people engaged and try to get the people interested in these sessions. We are planning to give an ICP power of attendance, a soulbound token by the artist Ejido Val. That is really cool. For achieve and get this power of attendance, soulbound token, we have 3 requisites. You have to attend minimum 5 sessions. We already have, this is the first one, but we will have 6. You have to attend 5 sessions. Then follow ICP North, the Twitter, our Twitter, ICP North America. And then you have to deploy Hello World plus additional feature. Hello World, yeah, in a few minutes, Jordan will explain what is exactly in Kybra, what is a Hello World. And then I will share with you at the end of the session the registration form that you have to put your GitHub, your name, and your email to apply for the proof of attendance, and also request free cycles. Cycles is so important in Internet Computer for developers because through the ICP tokens, you can convert cycles. And then in turn, you can use to pay for resource consumption. Cycles are important because reflect the real cost of computation. Anyway, in the next session, next Friday, Jennifer Tran, the dev relation of the Definitive Foundation, will explain exactly how request free cycles and how use the cycles to build on the Internet Computer. Yeah, let's start coding. Also, this is our Discord channel, ICP North America Discord channel. All the questions that you have, requests, cycles, or whatever, also you can reach out to us in our Discord channel. I'm happy to respond you and help you to building on the Internet Computer. And again, yeah, thank you so much, everyone, for your time. Over to you, Jordan.
Cool. Can you let me share? Perfect. So, yep. Hey, everybody. I am Jordan Last. I am the CEO of a company called Demergent Labs. We are building fundamental developer tooling on the Internet Computer. One of our main projects is the Python SDK that I'll be showing you. It's called Kybra. And we have another project called Azel, which is our TypeScript SDK. So if anybody's interested in TypeScript or JavaScript development on the Internet Computer, just know that basically everything I'm going to show you here has an equivalent in TypeScript or JavaScript. And maybe just to get a read for everybody, if you could respond in the chat, what do you guys know about the Internet Computer? Is everybody basically completely new, or is there some sort of experience people have? I'd just love to know a little bit before we get started. Okay. Yep. Huh. Okay. Perfect. Then we will assume everybody is completely new to the internet computer. So, okay, so that's about the internet computer. But how much do you guys know about blockchain development in general? Can you guys answer that? Just blockchain, Bitcoin, Ethereum, any kind of blockchain development or blockchain knowledge. What are you guys? What level are you guys at there? Okay. So you guys do have a basic understanding of blockchains. Perfect. Okay, great. Okay, that's very helpful. Thank you for responding. So let's just start with an overview of the blockchain space and the internet computer and where it kind of fits in there. So what is a blockchain, right? In my mind, how I view it is a blockchain is essentially a decentralized computer. It's not a single physical machine. Like if you have a web application that you're trying to host and run, that's generally going to be one physical server running, in a very specific warehouse in a very specific part of the world, owned and controlled by yourself, of course, but the actual physical hardware and a lot of the software will be controlled by a single company like Amazon or Microsoft or Google. And the problem is if that one physical server has any kind of problem, like the electricity goes out, or I don't know, the hardware is just old and breaks down, or somebody hacks into it, then your server is going to go down, and your application is most likely going to go down. By the way, if everybody could mute themselves, it seems like some people are not muted. Yeah, I know I'm not screen sharing. I'm just talking. Thank you. So yeah, in the normal world of web application or software development, we're going to have basically one or a small handful of machines. And the problem is that they're rife with central points of failure. That's one of the main problems with them. Contrasting that is the world of blockchains. For example, Bitcoin, it replicates all computations across thousands or tens of thousands of machines. And Bitcoin nodes, Bitcoin clients, they're all running basically the same piece of software. It's called Bitcoin Core. You can go on GitHub and you can just download it. You can boot it up with Docker. It's just a relatively simple piece of software. The whole network is basically Bitcoin Core. And if you could spin one up right now on your laptop, and it would start to try to connect to other, computers, people that are running Bitcoin Core, and together, the Bitcoin Core client listens for transactions and executes every computation, and everybody's doing the same thing. And because of its massive replication, that provides us a massive amount of resiliency and robustness, right? Because now what do you have to do to take down the network? You have to hack into hundreds, thousands, tens of thousands of machines. That's not very feasible. For example, China in the last year or two basically made it illegal to do Bitcoin mining, at least for a time. And some huge percentage of Bitcoin machines were taken offline all around the same time. It was like 30, it was some very large number, like 30 to 50% or something of the network, some very large number. What happened to Bitcoin? Basically nothing happened to Bitcoin. Bitcoin kept moving along. People kept up the ability to send Bitcoin transactions. So a blockchain computer, because of its massive amount of replication, it's also massively decentralized in key ways. and it becomes a very, very robust and a very secure platform to run applications. Now, Bitcoin, unfortunately, at the moment, is basically only capable of sending Bitcoins from basically one address to another. So it is a decentralized computer with extreme amounts of security and robustness, but it's not very expressive. There's not much you can do with it programming-wise. Of course, people are working on, ordinals and things, sovereign rollups. They're trying to do things, right? But at the core protocol layer, it's very difficult to do anything. And this is what Vitalik Buterin, the founder of Ethereum, thought in 2013 when he was very, very involved in the Bitcoin community. He imagined essentially a version of Bitcoin that would allow you to be much more expressive and not just send Bitcoin back and forth, but also be able to basically do any kind of arbitrary computation. And that's essentially what Ethereum is. Ethereum is a decentralized computer that has a virtual machine called the Ethereum virtual machine that has a Turing-complete programming language. It has a set of, at the lowest level, opcodes that actually let you perform loops and do other operations that are necessary to have basically a full general purpose programming language. So now we have a decentralized computer that is extremely robust, extremely secure. I mean, I think there's I don't remember how many, but tens of billions of dollars worth of Ether staked, essentially providing security to this network, that is also capable of performing arbitrary computations. So now we can do things more than just send Bitcoin or more than just send Ether. We can create, all the things that are being created on Ethereum right now. NFTs, decentralized exchanges, naming services like DNS, ENS, Ethereum Name Service, and a lot of right now it's very focused on financial or maybe identity use cases, but it's much more expressive than Bitcoin. But the problem with still that Bitcoin and Ethereum both share is that they are very, very, very slow, and they are very, very expensive. On Bitcoin, if you want to transfer Bitcoins, it's going to take at least around an hour for everybody to feel certain that the Bitcoin transfer has gone through. That's because of its probabilistic nature. And on Ethereum, though, the blocks are every 12 seconds. So every 12 seconds, you can see transactions. Can everybody hear me?
Yeah, I can hear you.
All right. That one person can. Yeah, and this is just the intro. We'll get into coding soon. So on Bitcoin, also, if you guys have any questions, just feel free to go off mute and ask, or do it in the chat. So Bitcoin is going to take at least an hour to be, to send the transaction securely. And on Ethereum, it takes about, it depends when you send your transaction, but in the worst case, it's 12 minutes about. So that's pretty slow. And also, both networks are very, very, very limited in the throughput, like the amount of transactions you can fit in per unit of time. Bitcoin, I think, just does a very small handful, 5 or 10 transactions per second. Ethereum's a little bit better, but it's still very slow. So, and it's expensive. Oh, go ahead. Did you have a question? Okay, so not only is the throughput limited, but also it's expensive. Think about it. If all computations are being replicated across all machines, essentially, that's going to, it's going to take a lot of compute resources, and it's going to be very expensive because you have to somehow pay everybody for running the same exact computation. And so Bitcoin fees are, I don't know. I did a Bitcoin transaction today. I think it cost me a couple dollars to just send some Bitcoin. And the Ethereum fees right now, I don't know. I think they're 45 cents for ETH transfers and maybe a few dollars for doing something more complex. So still in the grand scheme of things, we can't be paying that much money to just do simple operations, right? So what is the whole world, at least the whole world of blockchain, trying to do? They're trying to scale blockchain, right? They're trying to create versions of Bitcoin or Ethereum where you can do thousands or tens of thousands or millions even of transactions per second for, fractions of a cent. Just very, very, very cheap. And if we can do that, then we can have general purpose world computers that are truly that are decentralized, that are extremely robust against hacks, that are not subject to small groups of people deciding what can or cannot be done on them. And yeah, I mean, there's a lot of properties that we derive from decentralization. But in a nutshell, that's what everybody in blockchain is trying to do. The internet computer is a very, very specific, it's a blockchain essentially. It's a decentralized computer that has chosen a certain design and a certain set of trade-offs. And it's really trying to be as scalable as a cloud platform. So anything that you would be able to deploy to Amazon Web Services or to Microsoft's Azure platform or to Google's cloud, the internet computer is trying to be capable of that type of infrastructure, which is really something that Ethereum is not even close to being capable of at this moment. Ethereum is basically has a megahertz processor, right? Millions of instructions or cycles per second. Millions that everybody has to share. All apps that are deployed to Ethereum must share the same megahertz processor. Well, we're dealing with gigahertz processors in the normal world, and the internet computer provides gigahertz level processing. There's a question. So you're saying Bitcoin is slow and expensive, but blockchain is eliminating it? Well, Bitcoin is a blockchain. Ethereum is a blockchain. And there are other blockchains that are being developed to try and solve the problems with Bitcoin's slowness and with Ethereum's slowness. Ethereum is also trying to prove itself. There are all kinds of designs, there are all kinds of blockchains, and they're all trying to solve these problems. The internet computer is a specific blockchain that is solving these problems in a specific way. Yep. So the internet computer is going to give us gigahertz level processing for our applications. It's going to give us gigabytes of RAM. You have 4 gigabytes of RAM per application. It's going to give us gigabytes of storage. Every application can store up to 96 gigabytes of long-term storage. And it gives you a very general purpose programming environment. Ethereum is also general purpose, but the amount of compute resources are on the kilobyte level, the megahertz level. It's just a very, very restrictive environment. The internet computer is a much more expressive cloud-like environment. You can program in Python. You can program in TypeScript or JavaScript. You can program in Rust. You can program in a language called Motoko, that the Dfinity Foundation, which is the foundation that created the internet computer. That's a language that they created. It's a WebAssembly virtual machine at its core, which essentially allows you to write in many different languages. So the whole point here is the internet computer is a decentralized computer that is much more like something you would be used to from regular web development, something that has a lot of compute resources available to it. And that comes with some trade-offs, right? The internet computer is it's probably in some ways not as robust and not as decentralized as Ethereum or Bitcoin. It doesn't replicate things thousands or tens of thousands of times. It replicates things, 13 to 40 to 50 times. The amount of computers that are replicating all computations is small. And there's a bunch of other trade-offs, which we could get into, but maybe it's a little too in-depth for the moment. So that's the background. Does anybody have any questions about just blockchain in general or the internet computer before we actually dive into the documentation and start programming? Okay, then I will share my screen and we'll get going. So basically, this whole course is about the Kybra project. It's called Kybra. Kybra is a Python CDK for the internet computer. The word CDK stands for Canister Development Kit. You could also just call it a software development kit, SDK. A canister is just an application on the internet computer or a smart contract, essentially. So if you ever get lost, if you need to know where the documentation is or where the project is, just go to the GitHub repo. It's github.com/demergent-lab/Kybra. And this, you can see all the work that we are doing, all the releases. And I want to focus in real quick on this disclaimer. Kybra is a beta project. And so, it's new. You might run into bugs and things, and it may have unknown security vulnerabilities, right? We don't have tons of apps using Kybra at the moment that are live and that have been continuously operating. We don't currently have all of the testing infrastructure that we'd want. We have a lot of tests, probably a few hundred tests, automated tests. But there's an even more intense round of testing called property tests that we want to build for Kybra. We haven't done that yet. We're currently working on it for the JavaScript and TypeScript CDK, but we are not there yet on the Python CDK. We don't have security reviews or audits yet, and we're currently using a Python interpreter that is not CPython. So it's just less mature. So there could be some problems with it. So just keep that in mind. We would love to get to a 1.0 in 2024. What do we need to do that? We would love to use CPython under the hood and get true support for the C API and C extension so that you can literally pip install most things as long as the internet computer supports them and have those work. Right now, we don't have any support for native code, essentially. It needs to be pure Python, essentially. And then, of course, our automated tests, and then maybe some security reviews. We have a Discord channel that is separate from the ICP.Hub North America Discord channel. If you want to get in touch with my team, we look at those Discord channels all the time. So just so you know, you can also join that channel. And then finally, the documentation is here in what we call the Kybra book. One more thing, we have a directory here called examples. We have tons of examples, like 60 examples of how to use Kybra to build things. So if you ever need to know how to do something and you can't find it in the documentation, I highly recommend looking at these examples. And here you go. Here's real Python code showing you how to build things and how to use many of the Kybra APIs. So all kinds of examples covering all kinds of things. So that's the repo. Here's the Kybra book. You can find it here, demergentlabs.github.io/Kybra. The book's licensed under MIT, open source. Chapter 2 here. Just has some background info, a lot of what we just talked about, the disclaimer, the roadmap, a little bit about my company. If you do want to know a little bit more, mostly you could just look at our GitHub to see what we're doing. And then if you're interested in really diving deep on the benefits and drawbacks of using the internet computer and of using Kybra. If you want to compare and contrast and get a deeper understanding of why you'd want to use the internet computer or why you might not want to use it, highly recommend this chapter. Goes into all kinds of stuff like that. And really, I mean, we've talked about decentralization, but what benefits do we really get from that? And we think there are three main categories here. One is called ownership. So just a quick overview. On the internet computer or on Ethereum, you can build applications that don't have owners. Right? That's basically what a smart contract on Ethereum is. By default, if you deploy it, it doesn't have an owner. It's actually an autonomous piece of software that simply runs. That's a powerful concept. You can also build software that has group ownership. The internet computer is very, very good at allowing a group of people to control a piece of software. This is also something that's really not possible outside of a decentralized computer. So like us people, how many of us are there? 38 people in this call. We could hand out, credentials or NFTs or tokens or, just some form of authentication. And collectively, we could own a full stack application, front end to back end. We would be able to control all that code by, voting or delegating our votes or something, where no one has to go have one account with AWS or something like that. This is something that is, just not possible in the same way, I guess, on traditional cloud platforms. You can also build permanent APIs.
Recording in progress.
You can also build something called permanent APIs. Right now, think of all the APIs you might use on the internet. Basically, some URL that someone's exposing. They're all owned by like one person or one company. And in my opinion, they're quite finicky. You never know if they're going to stay around. Twitter, Facebook, probably many other companies have once provided APIs and then, restricted access to them. Imagine building your company on top of a Twitter or a Facebook API and then having them pull the plug. Like the risk is enormous to your company. On the internet computer, you can actually build APIs, HTTP APIs, that because they're autonomous or owned by groups of people would essentially be permanent or would be very, very, very difficult to shut down or change, which provides a very solid platform to build upon. A lot of this is all about credible neutrality. It's about making a neutral piece of software that isn't just going to change or block people, willy-nilly. Imagine a voting platform. Like I'm from Texas. We're about to vote on some things. I would love to know that the software that is tallying the votes has not been tampered with. I'd love to be able to review that software or have other people review it and know that it's not going to just change from under me. So that's what ownership gives you. There's also security. The internet computer provides a lot of things right out of the box. Right out of the box, all your computations are replicated across 13 to 40 machines, depending on your configuration. You have authentication built in. Everybody uses private key pairs to interact with the internet computer, and the internet computer is going to ensure that the public key is, everything, all requests coming in are signed, and that your application has access to that, address or public key, basically. A lot of things that you would have to configure and deal with on a cloud or a SaaS or infrastructure as a service platform, you just do not need to deal with on the internet computer. You also get some really cool threshold protocols. The internet computer can actually sign Bitcoin transactions and sign Ethereum transactions and sign transactions for many other blockchains in a way that is very secure relative to how you would be able to do it on a cloud platform. you can also relatively easily verify that the source code that you're looking at is what's actually deployed to the internet computer. And there's a very tight integration with Bitcoin and a tight integration with Ethereum that's coming. So very high security. And then the developer experience. There's a lot of things just built in. And in my opinion, it is an extremely simple platform, relatively speaking. As your app gets more complex and as you need to scale and stuff, some things get complicated. But the basic experience, I think, is quite simple. And we'll get into that. So yeah, let's just get going. Finally, chapter 3, installation. Yes.
Sorry, we have a question from John Lee.
Oh, okay. Sorry, everybody. At what point do you think hosting on ICP would be cheaper than hosting on AWS? I'm not sure it's cheaper. Yeah, I'm not sure being cheaper is one of ICP's strengths because everything on the internet computer is replicated. So on the internet computer, you're getting a lot of things out of the box that you're not going to get on AWS out of the box. So you have to think about all the costs of building your app on AWS versus all the costs of building it on the internet computer. So I think the internet computer is going to be very, very well suited to things that need what we're talking about here, right? If you want to build group-owned software or autonomous software or permanent software that needs to be credibly neutral, that needs to be extremely secure, then I think it might make sense to build on the internet computer. If you need it to just be cheap, the internet computer is probably not going to be good. It's not, in my opinion, it's not designed to just be cheaper. So hopefully that answers that question. But that doesn't mean in some cases it wouldn't be cheaper. But I mean, just thinking off the top of my head, right now, technically, any kind of read-only request doesn't get charged. So I guess for the moment, if you have a read-heavy application, like, I don't know, a blog, yeah, anything where people are writing very small amounts but reading and consuming a lot, maybe the internet computer would be good, or cheaper, I guess. But yeah, I don't think its strong point is being cheaper. Somebody has to do the updates. Alex, if you want to give more context, I think I know what you're talking about. You don't always have to update software. So, for example, Uniswap, one of the biggest decentralized financial applications on Ethereum. I mean, I guess I don't know all the technical details, but generally speaking, Uniswap deployed a version 1 and it didn't change. It's still there. Then it deployed a version 2 and that never changed and it's still there. And then they deployed a version 3 and I think they'll deploy a version 4. The versions that they deployed are just there. And what they do, well, they don't ever change them. They just stay. MakerDAO is another very, very large and successful decentralized financial project. That's the DAI stablecoin, which is a decentralized stablecoin pegged to $1. They went through like years of development and security audits and formal verification. That's basically creating mathematical proofs to ensure that everything's correct. To ensure that basically it was like building a piece of hardware. When you deploy a piece of hardware to the world, you don't get to take it back, right? You deploy the hardware and that's it. And they made sure that it was rock solid. They deployed it. To my knowledge, it was essentially perfect and has never been hacked and is still running unmodified to this day. So you do not have to update it. But what you could do is just keep deploying new versions and allow your users to switch to the new versions and make that choice themselves if you want to. But on the internet computer, it's very easy to also have group-owned software, right? Where if you do want it to be upgradable very easily, like the actual piece of code changes, you can also do that. but you can do it in a much more democratic, transparent, and hopefully thus secure way. So hopefully that answers that question. Okay, another question here. If the internet computer is full of fully autonomous software, it's very difficult to take down, then will there ever be a problem with running out of space, having too many redundant programs? So all software on the internet computer must be paid for, generally speaking. There's a unit called cycles, and cycles are created from a token called ICP. ICP is the token of the internet computer. Every application, which is also called a canister, has a balance of cycles. As network resources and storage resources and compute resources are used, that balance of cycles goes down. So if it goes down too much, your canister will eventually be frozen, and if it goes down all the way, it will actually be garbage collected and everything deleted. So I guess they are permanent as long as somebody provides, pays for that, essentially. So I think that solves that problem. Obviously, it's a difficult problem because you have to figure out how to pay for it. But for example, you could make it so that on every request, the user has to pay for it. And in that way, hopefully as long as someone is using it, then therefore it would still be able to run. Okay, John Lee asking that question because cost would be a big factor for developers to use ICP instead of AWS. True. I mean, I just want to reiterate, I don't think the internet computer is a replacement for AWS in all cases. What I was saying was that it's trying to be much more like AWS than Ethereum or Bitcoin or other blockchains are trying to be. The internet computer, I think, has very specific use cases right now because decentralized computation is so difficult, and because of the replication, it is not going to be suitable for all cloud use cases. But you should think about the ones that truly need decentralization and that truly need credible neutrality and truly need all the properties that derive from decentralization. What does the runway look like for on-chain ML inferencing with ICP? So inferencing is a lot more promising than training a model. Training will be just very, very, very compute intensive. And so it's just, at the moment, probably not feasible. They are talking about creating GPU subnets. The internet computer is partitioned into subnetworks, and they're thinking about basically providing GPUs on certain subnetworks. So training eventually might be able to work. Does inferencing use GPUs as well? I don't know as much as maybe you guys know. If that is the case, then that's good for that. But yeah, I think somebody has already deployed a simple LLM to the internet computer, and that has worked, which is good. On the Python side, right now, we only have support for pure Python. So we don't have C extension API support yet. So that might be a problem. But if you build pure Python things, inferencing could work. One thing you do need to realize, instruction limits. One of the biggest limitations of the internet computer right now is the instruction limit. So when you're doing your inferencing, it depends on if you're doing a read-only request or a write request. A read-only request gives you 5 billion instructions. I think it's roughly analogous to about 1 second worth of compute time. So if your queries if your inference only takes up to 5 billion instructions, and these are WebAssembly instructions, then you should be good. For a query message, which is the absolute cheapest way to do it, because right now it's free. If 5 billion is not enough for you, you can switch to an update message, which would give you 20 billion instructions. So that would be a few seconds worth of computation, I would say. So yeah, inferencing is a lot more promising than training. But I don't know. Only a few people, or maybe even one person, has seem to experiment with that so far. Okay, and then this final question: besides security and everything on chains, decentralized, what other incentives for wide adaptation or adoption of ICP? We all kind of know why Ethereum has wide adoption. In other words, what improvement ICP would have to make in the future to incentivize wider adoption? John Lee, if you do want to explain why Ethereum has wide adoption, I don't know what you're referring to, so that could help me answer the question. But what improvement ICP would have to make in the future to incentivize wider adoption? I don't know. Maybe you should clarify the question because I'm not sure how to answer it. The internet computer has a certain set of characteristics, like we talked about, gigabytes of heap, almost 100 gigabytes of storage, gigahertz of CPU, and is, because the network is partitioned into sub-networks, it is a sharded system that can horizontally scale right now very well. All these things are possibly attractive to your application. I feel like, I mean, that's one way to do it. I don't know if you're talking about marketing or other things, but yeah, maybe you could clarify and we can come back to that later. So, okay, thanks for all the questions. Keep asking them. So, yeah, perfect. Now let's actually get into some actual development, but I'm happy to answer questions about why the internet computer and any of its limitations and all that as well, because I think that is very important to deciding how to use an internet computer or not. So, chapter 3 is the hardest chapter because installing Kybra across everybody's different operating systems can sometimes be difficult. So, I'll try to be very careful here. Please follow these instructions exactly. If you think you know what you're doing, you could deviate, but if you don't do this exactly, there could be problems. You must use a Linux machine or a Mac machine or Windows subsystem for Linux if you're using Windows. You cannot just use Windows. You must use Windows subsystem for Linux. You can click here to figure out how to install that. Please use the absolute latest Windows subsystem for Linux that you can. I believe that would be WSL2. WSL1, I believe, will not work because of the internet computer tools that you need to install. There are basically two main dependencies we need. We need this very specific version of Python, Python 3.10.7. We need a special tool called DFX. These are the internet computer developer tools. And then it's very, very good to have the Python VS Code extension. So I recommend installing Python 3.10.7 like this using PyEnv. It's extremely simple to do so. Just run this command. Okay, now it's installed. Once you have it installed, so that's installing PyEnv. PyEnv will allow you to install a very specific version of Python, and we want 3.10.7. And it's going to install all this in your home directory. You don't need special permissions, I don't think, generally. And it's very easy to clean up. You could just delete the .pyenv directory if you need to. This just allows us to have one very specific location for our Python executable so that Kybra can use that essentially. Okay, once you have Python installed,
Jordan.
And yes.
Gordon O is asking you if Python 3.10.10 is okay.
I do not recommend using anything besides this exact version. So you could try it, but if you run into problems, just know that this is the version you should be using. Eventually, we would love to just not have these. What you have to understand is the internet computer is a completely new paradigm, right? It's a decentralized computer. It's a WebAssembly environment. And we are dealing sometimes with actual like protocol level limitations and things. So it's very difficult to get all this to work. And it is a beta project. So we are hopefully all these limitations will be lifted in the future, but we are working with what we've got for now. And we're just a small team. We are 3 people, and we're mostly focused right now on basically finishing up the JavaScript one. So the Python CDK, we've gotten to a pretty nice point, but we have not been developing or devoting as much development resource to it at the moment. So hopefully all these things will go away in the future.
Yeah. Alex is asking as well, is that for Linux or Windows PowerShell?
What is the question? You cannot use Windows PowerShell. You must use Windows Subsystem for Linux. If you're on Windows, you cannot use Windows without using Windows Subsystem for Linux. You must have basically a Unix system, either Linux, Mac, or Windows Subsystem for Linux. Do not even try to use PowerShell or the Windows command line. So all these are bash commands. Okay, I've got my Python installed. Now I will run. Yes.
Yeah, Shindu before is asking you, before to dive in here in these things, can you please explain the disadvantages of Ethereum and how Internet Computer is overcoming that?
Oh, yeah. Let me get back to that question. Let me just finish this for everybody, and I will get to that. So let's install DFX. These are the command line tools for the Internet Computer. This is not specific to Python or JavaScript or Rust or whatever. These are just the command line tools for the Internet Computer in general. So yeah, you just run the command. Takes, I don't know, 30 seconds on my machine-ish. If you do have any problems with that, you can look here. You might need to mess with your path to ensure that this is, once it's installed, to ensure that it works, we'll run a simple command. All right, I'm just going to make sure that everything's good. Okay, if you just run dfx -version, you should get back the version we installed. So mine is all set up just fine so far. Also, you're going to want, I highly recommend using VS Code as your editor, and you're going to want to install the Microsoft Python extension. So I'm going to make a project here by just making a new directory. I'll just call it Hello World. I'm going to open it up in VS Code, and I'm going to make sure that I have the Microsoft Python extension installed. Here it is. Look for Python by Microsoft, and there should be a button for you to click install. So highly recommend that. You're going to want that for the type checking. Once you have it installed, you should really, I highly recommend turning on the type checking mode to strict. So you just go to Preferences, Settings, and then you search for python.analysis.typechecking mode. So let's go to Preferences, Settings. Aha. It'll probably be off by default. You really don't want that to be off. At least basic, but I recommend just doing strict. So set that. And there you go. You should be set up and ready to go for the next step. So I will go answer that Ethereum question, and hopefully everybody can get all these tools installed while I'm answering that. Okay, here we go. Can you please explain the advantages or the disadvantages of Ethereum and how Internet Computers overcome that? Disadvantages of Ethereum. Also, I'm not claiming that the Internet Computer is the best blockchain in the world or anything. It is different it has a different set of advantages and disadvantages. Ethereum is much better at some things than a computer, and vice versa. So the disadvantages of Ethereum, it is, like I said earlier, very expensive and very slow. Let's just go look real quick. According to this, to just send Ether costs 85 cents. To swap tokens, which you can think of just as, a non-trivial computation, $3. It can't cost $3. I can't go to the grocery store and pay a $3 fee. I mean, maybe it'll be closer to 85 cents, but it's just too much, right? So that's one thing. And also, Ethereum's transactions per second, let's go to Etherscan. We are at 12.4 transactions per second across all of Ethereum. That's just not enough. How many transactions per second are happening in the entire world across all computations? It's a lot more than 12.4, right? Visa alone is like, low thousands on average or something, and like peaks at 10 or 20,000 just for that one application. So if we want to build, web scale type applications in a decentralized manner, we need to overcome that. Also, Ethereum forces you basically to use Solidity, and it uses its own virtual machine that is just not set up to be a very good compilation target. So we don't see, we don't see JavaScript and Python and Rust and things on Ethereum. Ethereum is working on all these things too. Layer 2s are coming that solve some of these problems. Ethereum itself is working on something called proto-dink sharding and full sharding or data availability sampling. But even with those improvements, I think the scale is going to be limited, and it depends. Very nuanced, and there's a lot to get into on these things, but that's a general overview. Can we use Eclipse? I really don't recommend using Eclipse. You could try it, but I definitely recommend using VS Code. Okay. Yeah, I don't recommend ever using Eclipse for anything, essentially. VS Code is, in my opinion, the best editor that I've ever used. But yeah, you could try it. All right, chapter 4, Hello World. We do only have a couple minutes left, so we'll see how far we get. Basically, this chapter is going to walk you step by step to making a very simple Hello World project. You just follow these steps, nothing crazy. First, you make a directory for your project. So I've made one. I called it Hello World. Okay, oh, fine. I'll follow this exactly. Let me close everything. Okay, all I did was make a directory. And let me open that now in VS Code. Okay, and then we change directories to go inside of it. We're going to make a directory inside of it called source. And we're going to make a couple empty files. The first will be our main entry point file. And the second will be a special configuration file called dfx.json. Then we're going to create our virtual environment using our very specific version of Python. And then we're going to source that virtual environment. We also want to get rid of this. And next, we will actually install Kybra. Make sure you create your virtual environment before installing Kybra. All right. So here we go. We've got all our stuff. Here's our main.py. It's empty. Easiest thing to do is just copy paste. And now we have the simplest possible application. Let's just continue deploying, and then I'll come back and explain that. The next thing you need is to copy the dfx.json file. This is the configuration file for all applications on the internet computer. Ours is a little bit complicated, but basically for every canister or app you make, you could just copy paste the same thing, and you just change the name essentially. We will simplify that in the future as well. And that's it. Next, we're going to start up a replica in the background. DFX start is actually going to start a local internet computer node. So it wants me to do clean. And it's called a replica. So basically, it's running the internet computer on your machine, just a local version. And now that I have that running, I can run dfx deploy. And dfx deploy is basically going to compile everything down into WebAssembly and take that canister and deploy it to the internet computer replica. On your machine, unfortunately, the initial installation process takes a few minutes, like 5 or 10 minutes. It depends on your machine. It's another limitation. I don't know how long this one will take, but while that's compiling, I will just explain this, and then I'll basically be done with the presentation for today. Basically, everything you want to do, you're going to import from the Kybra library here. We've imported 2 decorators. One is the query decorator, and the other is the update decorator. And we've imported the void type. Notice that things are typed here. We're actually using Python type hints. These are actually required at the moment. In a future version of Kybra, we will probably lift that requirement, but it's very nice right now. If you mark a method or a function with the query decorator, that marks the query decorator, or that marks the method as a read-only function. This means it does not actually go through the blockchain consensus. So it's very quick. The latency is very, very low. In this case, all we're doing is returning this global variable as a string. That's it. If you mark a method with the update decorator, it will go through the consensus mechanism. It will take a couple seconds, but it will allow you to persist your changes, and you will have the security that the internet computer provides. In this case, we just have a parameter that's a string. We aren't returning anything, and so we say that we're returning void. I just mark that I want to write into the global message variable, and then I just set it equal. This message variable is a global variable. It's going to be persisted automatically by the internet computer. It just stays there. Canisters are essentially eternal processes. They're just running. You don't need to do crazy stuff necessarily. And we're almost done deploying, especially this. Not every it doesn't take this long every time, but the first time or so, it's going to take a bit. It also is basically compiling and uploading the entire Python standard library for you as well. So let me pause there. Do we have any questions? Yeah, well, I mean, the deploy takes a bit the first time. So we are now over time. So is it on ICP chain now? I'm not deploying to the live network. I'm deploying to a local node. So it's not going to go on the live internet computer. But to do that, it's not that hard. You just need to make sure your thing has cycles, and then right here when you do DFX deploy, you just add a little thing, an option, -- network IC, and then it would deploy to the actual network.
Yeah, you're not sharing your screen.
Oh, yeah. Yeah, if you want to deploy to the actual network, you just say right here, -- network IC. You need to have your cycle wallet set up and everything. Okay, we're in the final steps. Doing the first chunk uploading. Yeah, I'll answer that question in a second.
Yeah, someone is asking, Gordon, what is the difference between DFX start background and DFX start background artificial delay? Here.
Yeah, I can answer that in a second. Okay, here's our canister. You can play with it from the browser, or you can play with it from the command line. I'll just show you the browser for now. Here are my two methods. I can query, which returns whatever's in the message variable, which is nothing. And I can set a message. Hello, world. Call it. And there we go. Hello, world. So it's all persisted there. Okay, and that is the end of that. And then the answer to your question is, what is the difference between DFX start -- background and DFX start -- background -- artificial delay 0? Artificial delay will let you set the delay for update calls. So I showed you the query decorator and the update decorator. The update decorator actually goes through blockchain consensus. On a local node, like DFX start gives you, there's an artificial delay to try to mimic the latency of the actual network. You can turn that off if you want. So that's what artificial delay 0 is for. And yeah, that's it for today.
Thank you, Jordan. Thank you so much. Yeah, tomorrow we will have the second session of TypeScript. For sure, like the first session is more like explain everything, and also Jordan explained really well the difference between internet computer and other layer ones. What is exactly the the evolution and the difference between Bitcoin, Ethereum, and internet computer. That's really awesome. Also, next week on Friday, Jennifer Chan, we will explain how it works, the cycles, if you want to build on the mainnet, as Jordan explained a little bit, but don't feel like afraid if now you don't know exactly how to build on the mainnet. Next Friday, before to start the session of Jordan, Jennifer, we will talk 10-15 minutes step by step how you can deploy your project or anything directly on the mainnet on the internet computer, and how you can request free cycles for all of you guys. Also, yeah, I'm sharing now a form. This form is for the registrations. Please fill out the form because the idea is also give you after the course proof of attendance, a soulbound token, and we need exactly tracking who is the people like is joining each class. And also we need your Discord channels to give you like the free cycles. This is the link I send you in the chat. And also we will upload all the sessions after each session. In that case, in a few hours, we will be ready in the ICP.Hub North America YouTube channel. Just Google it, ICP North America YouTube. And you can find, before we record the TypeScript course with Jordan as well, the 6 episodes are there. And now we will do the same with Python.
Hey, one more thing. If anyone wants to reach out to me on Twitter, X, whatever, Telegram, go ahead and do that. If you had any questions today about blockchain or anything you want to talk about in more detail, I have like a calendar link. You can just sign up for like a 30-minute video meeting or something. That's just open to the public. So if you do want to just ask questions, you can go find that link on my X profile.
Cool. Yeah, there's another question in regards the Discord channel. Yeah, in our Discord channel, we have now different universities because it's for our ambassador program, but we will create today another chat for DKU students, and all the questions that you have, you can drop in, or also the Demergent Labs in the Kybra book, you can see the in their website, they have also another Discord channel. You can directly reach out to them as well. Yeah, I think it's everything for today. If it's not more questions, thank you so much, guys. See you next session. See you tomorrow.